Hello friends, myself already Mahajan presenting my one more video on Leibnitz Theorem. Let us solve the problem. If y is equal to a into cos of log x plus b into sine of log x, then show that x square into yn plus 2. Here yn plus 2 means n plus second order derivative of y plus 2n plus 1 into x multiplied by yn plus 1. Yn plus 1 means n plus first order derivative of y plus n square plus 1 into yn is equal to 0. Yn means nth order derivative. And therefore, if you observe here the terms yn plus 2, yn plus 1 and yn, the derivatives of y is in decreasing order. And therefore, whenever we have such type of term, means it is the problem of Leibniz theorem. And therefore, to apply that Leibniz theorem, we consider given as y, it is a into cos of log x plus b into sine of log x. We call as equation 1. Then differentiating it with respect to x as it is function of x. Therefore, differentiating with respect to x, we get y1 as the first derivative. A derivative of cos is minus sine log of x into chain rule as it is function of function. Differentiation of log x is 1 by x plus b into differentiation of sine is cos of log x, and again chain rule, differentiation of log x is 1 by x. Then cross multiplying by that 1 by x, we get x into y1 as, first of all I will write down the positive term. That positive term is b into cos of log x, and this one is minus a into sine of log x. Okay, and then again differentiating it with respect to x. Here it is the product of two terms of x, therefore we apply the product rule. First term x, derivative of y1 is y2, second derivative, plus second term as it is y1, differentiation of x is 1, it is equals to b constant term, differentiation of cos, it is minus sine of log x, chain rule, differentiation of log of x is 1 by x minus a constant term, derivative of sine is cos of log of x, and differentiation of log x, chain rule, it is 1 by x. Again multiplying by that 1 by x, cross multiplication by 1 by x, we get x into x, that is x square into y2 plus x into y1 is equal to, I can take a common, minus common from this. The remaining terms are a cos of log x and plus b sine of log x. And then if you observe the given, it is a cos of log x plus b sine of log x is nothing but y, and therefore I will replace this term by y. It becomes x square y2 plus xy1 is equal to minus y, and if you transfer to left hand side, it becomes plus y and is equals to 0. We call this as equation 2. Therefore, this is the second equation. Therefore, once again I will repeat the steps. first I have differentiated it with respect to x. Whatever the result, once again I will differentiate it with respect to x to get equation number 2, where we have the term x square into y2 plus x into y1 and plus y. And therefore, if you observe here, the first term, the required first term, it is x square and yn plus 2. Yn plus 2 is nothing but the nth order derivative of y2. Yn plus 1 means the nth order derivative of y1, and yn means nth order derivative of y. And therefore, to get that nth order derivatives, we try to differentiate this equation to n times, or we try to find out nth order derivative of equation 2. Symbolically, I will write it as nth derivative of first term x square y2 plus nth derivative of xy1 and plus nth derivative of y, and nth derivative of constant term 0 is 0. And then we try to find out nth derivative separately. Therefore, here first of all I will obtain the nth derivative of the product x square into y2. X square, function of x, whose first derivative is 2x, next one is 2, and next is 0. Therefore, this term I will consider as v, and this one as u. And then applying that Leibnitz theorem, the first term is un, means nth derivative of y2. It is nothing but yn plus 2. Nth derivative of y2 is yn plus 2 into v1. V1 is, v is x square. Next one is n minus first derivative. Therefore, n minus first derivative, decrease it by 1, we get yn plus 1. Here it is started with n, decreased by 1, then decreased by again 1, like this. Therefore, if first one is yn plus 2, decreasing it by 1, we get yn plus 1 as the next. And v1 means derivative of x square, it is 2x plus n minus 1 by 2 factorial, again decreasing it by 1 to get that un minus 2, we get yn. Next one is derivative of 2x is 2. And as we get constant term whose next derivative is 0, we stop here. We call this equation 3. It is the nth derivative of the first term. Then we try to find out nth derivative of the second term, nth derivative of x into y1. Here derivative of x, first derivative of x is 1, next one is 0. Therefore, once again here also I will consider this as v and the remaining as u, and then applying that Leibniz theorem. The first term is un, means nth derivative of y1. Its nth derivative is yn plus 1 into v is x. Next one is n into un minus 1. Decrease it by 1. If we decrease it by 1, we get yn as next derivative. And to v1, derivative of x, first derivative of x is 1. And as we get constant, next derivative becomes 0. We stop here and we call this equation number 4. And nth derivative of y, last, is yn, and we call this equation 5. And then we add equation 3, 4 and 5 and then equate it to 0 to get the nth derivative of this equation number 2. Therefore, adding equation 3, 4 and 5, we get x square into yn plus 2 plus 2nx into yn plus 1. This 2 factor cancel with this 2. We get plus n minus 1 into yn. Then next one is plus x into yn plus 1 plus nyn and plus yn and right hand side is 0, therefore equal to 0. Collecting the similar terms in one bracket, we get x square yn plus 2, only one term. There are 1 and 2 terms of yn plus 1, therefore taking yn plus 1 common, as well as x is we can take common, therefore the remaining terms are here 2n, and when we take x into yn plus 1 common, remaining is 1, therefore that term is 2n plus 1 into x multiplied by yn plus 1. Then collecting the terms of yn, 1, 2 and 3 terms of yn, therefore taking yn common, we have n into n, that is n square minus n plus n and plus 1. And if simplifying it, we get x square into yn plus 2, then plus 2n plus 1 into x into yn plus 1, no change in it, and minus n plus n get cancelled. The remaining term is n square plus 1 into yn is equal to 0, hence the required result, hence proved. One more example on Leibnitz theorem I will discuss in my next video. Therefore, if you like my video, please share it, as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you.